Okay, we're working on section 5C from the back of the book, and I'm picking up on page 3 about halfway down the page. Example. The table below gives the order of the presidents of the U.S. and the ages at which they first took office. So they list the presidents from president number 1, 2, 3, all the way through 43 and 44, which is up to current Barack Obama as the 44th president of the U.S. And then for each of those presidents, they list the age. So when they were elected. So apparently, according to this, George Washington, our first president, when he was elected, was 57 years old, and Barack Obama, our 44th president, when he was elected, was 47 years old. And they want us to take this data, and they want us to group the data using age bins, starting with the group 40 through 44 years old, and they want us to include relative frequencies. So first of all, as far as the bins goes, what we want to do is make a table, and we want to make age bins, it says. So I'm going to put an age heading here, and then I'm just going to draw a line here to separate that column from other ones that we're going to do. And they say to start with the group 40 through 44. So the way I would write that is 40-44, which would be read as 40 through 44 years old. And then I'd think about what group would come next. And for the next group, you might want to start at 44, but what you need to know with the through symbol is that 44 is already included here, so that we'll go up to the next higher age, which would be 45. And then when you think about the right-hand boundary here, you need to look at this and say, well, how did I get from 40 to 44? And the answer is I add 4. It has to be consistent here, so 45 plus 4 would be 49. And then at this point, you might notice that the vertical gap is 5, both on the left side and the right side. When you see that, it might be easiest just to start adding 5 down the left and say, okay, my lower boundaries are going to be 40, 45, 50, 55, 60, and so on. And then as far as this and so on goes, we need to think about, well, how far should we go with this class grouping, and that depends on how old the oldest person was when they were elected into office. So if we scan through these ages looking for the oldest one, we have a 61-year-old, there's another 61-year-old, now 64, and then continuing to scan, haven't got 64 beat, but then right here with Ronald Reagan, our 40th president, we hit 69, and that's the oldest one in the table. So when you're thinking about that question of how far should I go with my grouping, you have to go far enough to contain the oldest or the biggest data value, which in this case would be the oldest president. So I think 65 will do that, and I'll verify that in a second by looking at the right-hand boundaries. Continuing to add 5 onto the right-hand sides, we'd have 54, 59, 64, and 69. So when we see that the 69-year-old president would fit in this class, we can end there. And by the way, it's also worth noting, why did we start with 40 through 44? And so for that, we'd be looking for the youngest president that was ever elected. So let's look for a young one here. There's a 54-year-old, that's beat by 51. Here's a 48-year-old, and there's a 46-year-old. There's a 42-year-old, and then there's a 43, that's close, but it looks like the 42-year-old is the youngest. So we want to make sure, let me go ahead and highlight that one too. When we set up our classes, we want to make sure there's room for the smallest data value up to the largest data value. One other point to make when we look at the classes, you might think, well, if the youngest one was 42, why not start at 42? Well, if we're going to go up in 40 in fives from 40 to 45 to 50 and 55, I'd much rather start with a multiple of 5 than something a little odd like the 42. So you don't have to start at your smallest value. You want to start at a nice number that is a little smaller than your smallest value so that you can have a nice numbering on the edges there. So there's my grouping, and then they want me to do a group data table, and one of the things that we'd put in there would be a frequency. So we'd want to think about how many times did we have a president in their lower 40s, how many times did we elect a president in their late 40s, lower 50s, late 50s, lower 60s, and late 60s. So one technique for doing this is just to scan through and try and count. So I'm going to go through looking for presidents that when they were elected were in their lower 40s. And I don't remember seeing too many of those when I was looking for the youngest. There's our 42. I'm going to draw a line through that just to kind of show that I've counted that. and then we had this 43-year-old, and I don't think there's anybody else that was elected in their lower 40s. So I'll put a 2 there just to represent that that happened 2 times that we had a president in their lower 40s. And now we start looking for the ones that were in their late 40s and crossing them off as we go along. So let's see, here's 1, 2, 3, 4, 5, 6, and 7, and it looks like that's it. So 7 times we elected a president who was in his late 40s, and then we start looking for the lower 50s and see how many of those we can find, and that's anything from 50 to 54 years old. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it looks like 13 times we elected somebody to be president when they were in their lower 50s. How about late 50s? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it looks like that's it for that one. We just continue on with this pattern. We're almost done. So we want to look at the early 60s. So we've got 1, 2, 3, 4, 5, 6, 7 of those. And then finally we're looking for presidents that were in their late 60s when they were elected. And we have 1 there. Got almost everything crossed off at this point. There's another 1 there. And then our 3rd one there. So that is the main part about making a table, is setting up what your bins are going to be, making sure that it'll hold the smallest data value up to the largest data value, and that you're consistent with the way the spacing and numbering goes. And then you start looking through your data, trying to find how many fall in each class. I think it's really important that you cross those off as you go along, and let me just show you why real quick. If we go through and add up these frequencies, we should get 44, because according to the chart, there's been 44 presidents so far. So if we do 2 plus 7 plus 13 plus 12 plus 7 plus 3, just adding up these relative frequencies right there, that should give us the 44. I press enter and I do see that I have 44. So that means I didn't miss anybody. I got every president thrown into one of those categories. And the point about crossing them off is that if this had been 43 and I had not crossed things off, I would know I missed something, but I'd have no idea which one. If I had crossed them off as I went along, I could just go back and look for the one item that wasn't crossed off, and wherever that was, I would increase the frequency by 1. So if you cross things off and you do make a mistake, you can quickly fix your mistake rather than just having to start over. Alright, and then they also asked us in this table to include relative frequencies, so I'm going to go ahead and add that column. And when you do relative frequency, you're just doing the frequency divided by the total, and then you're going to express that as a decimal. So you'll actually think of it as a percentage, but you'll write it as a decimal. So if we go through and say, okay, how often have we elected a president that was in their lower 40s? And we can say, well, that was 2 out of 44 times. But then we can think of that in decimal form as 0.0455. I'm just pointing out something with the rounding. That was a 4, but it's followed by a 5, so I'd round up. I can think of that as about 4.5%. So I could say it's happened twice, or I could say 4.5% of our presidents have been in that age group. And then for the 7, we just continue that same fashion. So 7 out of 44 would be 0.1591, again rounding the 0 up because of the 9. And we could say how many of our presidents have been in their late 40s when they were elected, and about almost 16%, like 15.91%. How about early 50s? 13 out of 44, which is 0.2955. And late 50s, 12 out of 44, which is 0.2727. And 7 out of 44 I could divide again, but it's not going to come out differently than last time, so I can just copy my work from above. And 3 out of 44 That would be 0.068, and then it's a 1 but followed by an 8, so I'd make that a 2. So there's two ways we can express our grouping here. We can say that if you look at how often we elect a president, or how many of our presidents were in their late 50s when they were elected, you could say that happened 12 times, but you could also say it happened about 27% of the time, and both of those have their uses. Just like we want to add up the frequencies and make sure we get the right total, we'd like to add up the relative frequencies and make sure we get the right total there. And so if you think about what is the right total, it should end up being 44 in the numerators, and then all of them divided by 44. So this total should be 44 out of 44, or 1. So let's see if we get that when we add these up. So 0.0455, 0.1591, and so on. And I actually get something a little bigger than 1. Whatever I get, I'm going to put, unless it's obvious that I've made a mistake, and then I'll try and check for the mistake. But you might wonder why aren't we getting 1, and the answer is fairly simple. On all of these percentages, we can just look at this last one here. We didn't get 0.0682 on our calculator. We got 0.068181882. When you shorten that up and round it, whether you round up or down, you're bringing in error. A lot of times your round ups and round downs will balance and you'll get the one you expected, but sometimes, like this one, we ended up rounding up more often than down and we didn't get a balance and we ended up a little bit over. It's not a mistake that we made, it's not anything we need to change. It just shows, illustrates that idea that when you round something, a little error gets introduced, and we should just put whatever total we get. And then the other thing that's worth pointing out is, would we ever be concerned down here? And the answer is yes. If you get something like 3.8, there's no way that's just rounding error. Even if you get 1.0009, that seems like too big to just be rounding error. So things that tend to be acceptable is getting a 1 in all zeros, or a 1 and 0001, maybe even a 2, or you might come up under 9999, or maybe even 9998. The more you get away from the 1, the more suspicious you should be that you've made some error other than rounding. But if you're just off by 1 digit in the last place, often that's just rounding error and not any mistake that you need to fix. So that's what our group data table would look like, where we're going to list the age bins, the frequency, and the relative frequency. Okay, continuing on with our problem about the ages of our presidents of the U.S. when they were elected. They want us to create a relative frequency histogram for the age data. So I'm going to make the histogram by drawing a vertical axis on my graph grid and a horizontal axis on my graph grid. And the horizontal axis, I'll always make that whatever the variable was. If we look back at our group data table real quick, in fact, let me kind of overlay those a little bit. The first column where we did our binning, however we headed that, which in this case was age, that would be our variable. So our horizontal axis is going to be representing the age of these presidents when they were elected. And then I want to think about how should I number that. So we want to look at the bins that we have. First of all, how many bins? 1, 2, 3, 4, 5, 6. And we might think, well, how many squares do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 bins and 14 grid squares and 6 bins that we need to graph. If you did the division there, you could use about 2.3 of these squares per bar. Well, I don't want to use a decimal amount, but it does look like there's room for me to make each of the bars in my bar graph 2 squares wide. And I think it's worth noting, we'll see this a little bit further down the page, but a histogram is a bar graph. It's a type of bar graph. We'll get a little bit more detailed on the definition down below. So when I go to do this, if I'm going to make each bar 2 wide, I might go ahead and start here with my first lower limit on my classes, which was the 40. And then I'm going to make each bar 2 units wide. And every time I get 2 units over, or 2 squares over, I'm going to start a new bar. And that'll be the next lower limit. So this would be 45. And then 2 over, and my next one, which is 50, and 2 over for the 55, and so on. So this would be the 60, 65, and 70. And so I'm going to end up drawing my bars using this as lining up with what the bins are and trying to decide where the bars are drawn. And then I want to, on the vertical, draw bars, and I want the bars to represent what the relative frequency is for that bar. So to do that, I need to think about scale, but first of all, I'll label the axis. This axis is going to be relative frequency. But I want to think, how should I number that so that my bars fit well on the graph? When you go to do that, think about the maximum relative frequency, which in this case is 2955, and take that max relative frequency and divide that over how many squares you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And round that up to something kind of nice. So if we started at 0 and went up 0.0268 per square, we'd end up hitting this 0.2955 at the top. But no one wants to read a graph that's numbered that way. So we want to round this up to something nice, maybe 0.03, maybe 0.04. I'll go ahead and go with 0.03. So this would be 03, 06, 09, 12, 15, 18, 21, 24, 27, and 30, and then 33 at the top, but I'm just marking every other one. So how do I know that's a decent scale to use? Because my biggest relative frequency is 0.2955. That will be up to about here, and what I'm looking for is for my tallest bar to go over halfway up so that I don't have squashed bars, and I definitely want it to fit. Now when you go to draw your bars, they go from lower limit to lower limit. So we're going to draw our bars from lower limit to lower limit. Also referred to sometimes as the lower boundary. But the lower limits or lower boundaries or even lower cut points of my classes are these left sides, 40, 45, 50, 55, 60, and so on. So when I draw this first bar that has a relative frequency of 0.0455, I'm going to draw it from 40 to 45. So let's see, 0.45 would be about halfway between 03 and 06, and that would be my first bar going from 40 to 45. And I know the 45-year-olds are not in that group, but the way this would be read on the bar graph is from 40 through everything up through less than the 45, so people who are familiar with this would know the 45 is actually in the next class. When we go to do the next one, for the late 40s, we need to make it all the way up to 0.1591. So here's my 1.5 line. So this is 1.5, 1.591 would be just a little bit above that, and going from 45 to 50. And I just keep continuing on in that fashion. I'll go ahead and fold this up a little bit so we can see those other ones. The next one is 2955. So that would be the one that's almost all the way up to 30. So I'll draw that one in. The next one is 2727. This is the 27 line, so just a tiny bit above that. And then 1591, we already did that. That's this height, so we just match that again. And then finally finishing off with this 0682. There's the 06 height, so we want to go a little bit above that, maybe like this. So at this point we've finished off our graph, and now I just want to talk a little bit about why somebody would make this graph and why they would do the grouping. If you go back to the original and you just look at this raw data they gave us at first, when you first looked at it, you might have just scanned through and kind of looked at the numbers and went, okay, George Washington was 57, Barack Obama was 47, but maybe you don't see very many patterns. Once you start to group the data, you can start seeing things like it's pretty rare for us to elect somebody in their lower 40s, and it's pretty rare for us to elect somebody in their late 60s. But on the other hand, we seem to really love electing 50-year-olds because we've elected 13 times, or almost 30% of the time, someone in their early 50s, and 12 times, or 27%, we've elected someone in their late 50s. And so 25 out of our 44 presidents have been in just their 50s. And that might not have been obvious when you look at the raw data. And then when you come over to the graph, that just kind of illustrates that even more. you've got the bars showing us the tallest bar is in the early 50s, and right next to that, almost as tall, is late 50s, but quite a drop-off for the late 40s or early 60s, and even bigger drop-off if you go to early 40s, late 60s. So a lot of people are going to pick up that pattern a lot better when we show them a graph than when we just show them the ages of all 44 presidents arranged in a chart like we were given to begin with. Before we wrap things up with this histogram, I just want to point out one little thing that I forgot to do. When I set up my horizontal number line, I started at the 40 and then went every 2 squares was 5, and I thought that made a good spacing for my graph. But if you count that backwards, 50, 45, 40, this would be 35. So apparently I've cut out a big section of the scale between ages of 0 and 40. And so whenever we do that, we're supposed to put the double slash mark like we did back when we were doing scattergrams. So that should have been included as well. So make sure you include that on your graph. Now let's go ahead and point out some of the key differences between graphing quantitative data like we just did for these ages of the presidents and the categorical or qualitative data that we did at the beginning of this section. When you're doing one like we just finished for the ages of the presidents, which is a quantitative variable, there's a few things we want to note. One of them is that the bar graph is called a histogram. And I think that one's worth just contrasting right away with qualitative. If it's categorical or qualitative data, then the bar graph is simply called a bar graph. But when we know that it's quantitative variable, we'll refer to it as a histogram, and we see that difference up here in the words. And it's kind of important to know that, because when you move on to statistics and you start using statistical software to draw these graphs for you, you'll see that if you ask for a histogram but all of your data is categorical, it won't show any columns because it'll be looking for numerical ones. So it's important to know the names: histogram for quantitative and bar graph for categorical. So now let's go ahead and finish off some of the notes about the quantitative type, like for the ages of the president. So when we draw our number line here, we number the lower class boundaries or lower class limits on the number line rather than labeling each individual bar. And then when we do that numbering and draw in our pictures, the bars go from the lower class boundary of the current class to the lower boundary of the next class. So when we see that a bar goes from 40 to 45, we actually know that 40 is the lower limit or boundary of the class we're on, and that 45 is for the next one. And one of the reasons we do that, going from 40 to 45 rather than just 40 to 44, is that way there are no gaps between the bars unless we have an empty class. When we're doing a histogram, when we're working with quantitative data, we don't want it to look like there was a gap, because that looks like there was something that could have happened and it just didn't. But really, as soon as you age out of 44, you're into the 45 category, so there isn't really a gap of age there that could have happened and didn't. But if there was an empty class, then we'd show a section with no bar in it to show exactly that, oh, it could have happened, but there was none in there, so here's this gap. So that going from lower limit to lower limit philosophy means there will not be any gaps unless you have an empty class. And then going back to the ones we did at the beginning of this section that were categorical, we're going to call those bar graphs. And there actually is no number line on your horizontal axis. We just label each bar. And so we put country names like Italy or France or something rather than having a number line like 40, 45, 50. And then also, when you have categorical data, there are gaps between the bars. There's no natural flow from when you get too big for one word, you're in the next word, like there is for numbers. So we just show them as distinct bars with gaps in between them. All right, that wraps up section 5C.